morning, ladies and gentlemen. If you survived math to this point, you're up to your last chapter test, which is good. Before we jump into chapter 9, let's go back to chapter 2.4 with direct variation. Okay, and in your warm-up here, I can have you graphing linear functions. Remember, this is your y-intercept. This here is my slope, which sometimes it's beneficial to put it over 1 as a fraction. This is my rise, this is my run. So start with your y-intercept at positive 2. That would be it, that's 0, 2. I'm going to go over 1 down 3, marching off my slope. Okay, so as I do this, I go backwards. You can see right here would be your line 4, y equals negative 3x plus 2. Number 2. Okay, again, my slope here is negative 1 over 1. My y-intercept is 0. So I put a point at 0, 0 on the y-axis, over 1, down 1 every time. So basically you can see here, I'm going to have this diagonal line going backwards. And here we go. There's my line 4, y equals negative 1x. And let's finish up with this guy, slope of 2 over 1. So finally a positive slope. And again, my intercept is 0. So there's my y-intercept. So 0 is my y-intercept. I'm going to go over 1 up 2 every time. And I'm going to do the same thing coming back, stay on that same pattern. And here we go. Okay, so there's your warm-up. Hopefully that was nice, easy, linear equations of graphing. So you can see your goal is to write and graph direct variations of equations. Okay, and here you go. Most direct variation is in this form, y equals kx. If the salsa recipe calls for 2 tomatoes to serve 4 people, how many tomatoes should you use if you want to serve 12 people? So what I'm going to do is I'm going to assign this x, this is going to be y. So what I'm going to do is say, okay, 4 people will be equal to k times 2. So if I solve for k here, I have 2. So my equation would be equal to y equals 2x. All right, so we're serving 12 people. So when I set this up, I got 12 people equal to 2 times x. X is number of tomates, or tomatoes. Okay, so how many tomatoes are we going to need? Well, if I divide by 2, we're going to need 6 tomates. Okay? Now, if x represents the number of tomatoes and y represents the number of servings, which is what we had, make an equation. So that's basically what I did here. I used y equals 2x. It says these variables show what is called blank variation. As you can see in your title, you're dealing with direct variation. What makes it direct is you have no b value here. The formula for direct variation is y equals k times x, which is what I was just talking about, where k is called the constant of variation. So hopefully that's helpful, right? I'm going to jump down here. Okay, in questions 2 through 4, the variables x and y vary directly. Okay, write an equation that relates x and y. So we're going to be in this form, constant of variation. So k is what we're going to solve for. Then we're going to find the value of a, and then we're going to find the value of this. So first let's solve for k. This is negative 9 equals k times 3. So k is negative 3. So our equation is net y equals negative 3x. Okay? So when x is 6, what are we going to get here? Well, what's negative 3 times 6? Y is equal to negative 18. So there's a, and then here comes b. b is when x is equal to negative 1. So negative 3 times negative 1 is positive 3. Okay? So there are solutions for a and b. If we go to blue here for number 3, first off, let's solve for our constant k. So divide over by 22. So am I going to reduce this? This is 2 over 11. There's my k. So y equals negative 2/11 times x. First part is solved for. Let's go through letter A when x is 6. Okay. Let me rewrite that. So letter A, let's do when x is 6. So I have y equals negative 2 over 11 times 6. So basically I'm looking at negative 12 over 11. Letter B, x is equal to negative 1. So I have negative 2/11 times negative 1. So this would be positive 2 over 11. Okay. Jumping through the purple hoop here. So I have y equals k times x again. So we're looking at negative 1/4 equals k times 2. Rather than divide by 2, I'm going to think of this as multiplying by a half both sides. So that gives me k equals negative 1 over 8. So my equation is negative 1/8 times x. All right, let's go through A. Again, x is 6. So I'm going to get negative 1/8 times 6, which is basically going to be negative 3 over 4. Going through x equals negative 1, we get y equals negative 1/8 times negative 1. We have positive 1/8. Okay? And that takes care of your front of your variables. So I'm going to pause here and flip over the second page. 5 through 6 on the back here. I'm going to do 5 in blue. It says identify the slope of the x-intercept and y-intercept very directly. So we're going to do our equation first. First thing we need to do is solve for it. So this is 4 equals k times 1. So k is clearly 4. Our equation is y equals 4x. So let's plot this. I have a y-intercept of 0, slope of 4. So every time I go over 1, I'm going up 4. Of course, when I say go over, I mean to the right. Okay? All right. So to get back to the problem here, let's identify the slope. Slope is equal to 4. My x-intercept is 0, 0. The y-intercept is 0, 0. Okay, finally graph function and identify 3 pairs of points on each line. So here's 0, 0. This was 1 up 4. This is 2, 8. Back here, negative 1, 4, negative 4, and negative 2, negative 8. Okay, so there's your first one. Now you have a baseline of what you expect in 6 here. First thing I want to do is solve for k again. So 8 equals k times negative 2. So k is equal to negative 4. Y is equal to negative 4x. So 0, 0, over 1 down 4, and so on. Again, there we go. Okay, let's plot some points a while. 0, 0. We have negative 1 up 4. I got negative 2 up 8. I got 1 down 4. And I have 2 down 8. Okay, so there we go. X-intercept and y-intercept. So x-int and y. Both are 0, 0. Okay, so there you go for that. All right, so as we were talking here, we got our slope. I need my slope yet of m. Slope m is negative 4. And here are my intercepts. Okay, last one we'll do in pink. Let's solve for k first. Negative 9 equals k times negative 3. K is positive 3. So y equals 3x. Okay, so if I go 0, 0, over 3, over 3, I should say up 3, and then 3 going this way. So here we go. Try to make that as straight as I possibly can. I got 0, 0 here. I'm 1 up 3. I'm 2 at 6. And 3, we're at 9. Going backwards, I got negative 1 down 3. I got negative 2 down 6. And I have negative there's our graphs. My slope is equal to 3, my x-intercept, and my y-intercept are to come here. Again, 0, 0 for both. Okay? And moving right along. So, pause me. Okay, ladies and gents, last two problems for the day. And we'll basically go through 8 and 9 here. Variables x and y vary directly. Y is 18 when x is 36. So again, we're still saying y equals kx. 18 equals k times 36. So k is 1 over 2. Jumping down here, we'll have 42 equals k times 3. So k is going to be equal to, not 7, 14. So I divide this by 3. So, as far as my equations go, this would be a half x, and this one will be 14x. Okay, how are we matching up? So it looks like letter D. Okay, and let's go to the next one. How about letter A? Okay. And that will be it for today. You have 3 real-life examples down there. I'll let you pick and choose what you would like there. I would say when you buy groceries, you buy fruit, you'll have a unit rate. Anywhere where you have a unit rate in purchasing could definitely be under that. So come up with some good ones. We'll see you guys in class here in a second. So ciao, and talk to you soon. See you guys.